Alright, so in this video, I'm going to solve the equation x to the power of 4 minus 16 is equal to 0. So, my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. What I'm first going to do is rewrite x to the power of 4 as x to the power of 2 times 2. So now I have x to the power of 2 times 2 minus 16 is equal to 0. Now from here, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2 is equal to x to the power of 2 to the power of 2. And I have this minus 16 is equal to 0. Now from here, I'm going to rewrite 16 as 4 squared. So now I have x to the power of 2 to the power of 2 minus 4 squared is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 4. So this turns into x squared plus 4 times x squared minus 4 is equal to 0. Now I can divide this into two equations. I have x squared plus 4 is equal to 0 and x squared minus 4 is equal to 0. So for x squared plus 4 equals 0, I'm going to subtract 4 on both sides. So I get x squared is equal to negative 4. And now I'm going to take the square root on both sides. The square root of x squared is simply x. So I get x equals the square root of negative 4. Now the square root of negative 4 is the same thing as the square root of 4 times the square root of negative 1. And the square root of negative 1 is equal to I. So I get x is equal to 2i. And this is positive or negative. Now for x squared minus 4 equals 0, I'm going to simply add 4 on both sides. So I get x squared is equal to positive 4. And now if I take the square root, I get x is equal to positive or negative 2. So my four solutions are x equals 2i, x equals negative 2i, x equals 2, and x equals negative 2. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048, and 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4000 is 8000, and 8000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.